Let us see the first question. A big data analytics company is using Kinesis Data Streams KDS to process IoT data from the field devices of an agricultural sciences company. Multiple consumer applications are using the incoming data streams, and the engineers have noticed a performance lag for the data delivery speed between the producers and consumers of the data streams. As a solutions architect, which of the following would you recommend for improving the performance of the given use case? So there are four options for this question. This is option 1, this is option 2, this is option 3, and this is option 4. You get 10 seconds to answer this question, and your time starts now. Time up. Now let us analyze the answers. So option 2, swap out Kinesis data streams with Kinesis data firehose, is incorrect because it's used for loading data into analytics tools, not improving stream performance. Alright. So this is why option number 2 is the wrong answer. Option number 3, swap out Kinesis data streams with SQS standard queues. This option is also incorrect because SQS is a messaging service, not a real-time data streaming service like KDS. Alright. This is why option number 3 is also the wrong answer. Option 4, swap out Kinesis data streams with SQS FIFO queues, is incorrect because SQS FIFO queues are for message ordering, not high performance data streaming. Alright, this is why option 4 is the wrong answer. Option 1, use enhanced fan out feature of Kinesis data streams, is correct because it allows multiple customers to receive data from a stream with higher throughput and low latency. Alright, at the end, this is why option number 1 is the correct answer. Got it? So this is our next question. You are a cloud architect at an IT company. The company has multiple enterprise customers that manage their own mobile apps that capture and send data to Amazon Kinesis data streams. They have been getting a provisioned throughput exceeded exception. You have been contacted to help and upon analysis, you notice that messages are being sent one by one at high rate. Which of the following options will help with the exception while keeping costs at a minimum? So these are the four options: option 1, option 2, option 3, and option 4. Got it? You again have 10 seconds time to answer this question, and your time starts now. Time up. Now let us analyze the answers. Option 1, increase the number of shards, is incorrect because it increases costs and might not fix the issue if messages are still sent too quickly. Got it? This is why option 1 is the wrong answer. Option 2, use exponential backoff, is incorrect because it only delays messages, not reducing the number of requests. Okay, so this is why option number 2 is also the wrong answer. Option 4, decrease the stream retention duration, is incorrect because it only affects data storage, not the exception. Got it? So option number 4 is the wrong answer. Option 3, use batch messages, is correct because sending messages in batches reduces the number of requests, avoiding the exception and keeping the costs low. That is what we want, and this is why option number 3 is the correct answer. Okay, let us move to the next question. A highly elastic application consists of 3 tiers. The application tier runs in an auto-scaling group and processes data and writes it to an Amazon RDS MySQL database. The solutions architect wants to restrict access to the database tier to only accept traffic from the instances in the application tier. However, instances in the application tier are being constantly launched and terminated. How can the solutions architect configure secure access to the database tier? You have got 4 options. This is option 1, this is option 2, this is option 3, This is option 4. You have 10 seconds time. Your time starts now. Okay, time up. Now let us analyze the answers. Option 1, configure a network ACL on the database subnet to deny all traffic to ports other than 3306. This option is incorrect because network ACLs can dynamically update with changing instances. Okay. So this is the wrong answer, option 1. Option 3, configure a network ACL on the database subnet to allow all traffic from the application subnet. This option is also incorrect because allowing all traffic from the app subnet is too broad. So option 3 is the wrong answer. Option 4, configure the database security group to allow traffic only from port 3306. This option is incorrect because allowing only port 3306 doesn't ensure only app tier instances can access. Option 2, configure the database security group to allow traffic only from the application security group. This option is correct because security groups can dynamically update as instances change, ensuring only app tier instances can access the database. Alright, this is why option 2 is the correct answer. Okay, let us move to the next question. A company is developing a document management application on AWS. The application runs on EC2 instances in multiple availability zones. The company requires the document store to be highly available and the documents need to be returned immediately when requested. The engineering team has configured the application to use EBS to store the documents, but the team is willing to consider other options to meet the availability requirement. As a solutions architect, which of the following will you recommend? So I think again I've got 4 options. Yes, this is your option 1. This is your option 2, this is your option 3, and this is your option 4. So you can see it is a little bit difficult to navigate through the options. This is why if you want some more time other than 10 seconds, you can pause the video and take your time. Alright, I'll provide you 10 seconds itself and your time starts now. Time up. Now let us analyze the answers. This is option 1, create snapshots for the EBS volumes regularly and then build new volumes using those snapshots in additional availability zones. This option is incorrect because EBS snapshots and new volumes don't ensure immediate document availability. Okay, this is why option number 1 is the wrong answer. Option 2, provision at least 3 provisioned IOPS EBS volumes for the EC2 instances and then mount these volumes to the EC2 instances in a RAID 5 configuration. Okay, this option is incorrect because RAID 5 with EBS volumes increases performance but not availability. Okay, option number 2 is also wrong. Option 3, set up Amazon EBS as the EC2 instance root volume and then configure the application to use S3 Glacier as the document store. This option is also incorrect because S3 Glacier is for long-term storage, not immediate access. Okay, so option number 3 is also the wrong answer. Option 4, set up Amazon EBS as the EC2 instance root volume and then configure the application to use S3 as the document store. Okay, this option is correct because S3 provides high availability, durability and fast access to the documents, meeting the requirements. Okay, this is why option 4 is the correct answer. Okay, option 4 is the correct answer. Let us proceed with our next question. Okay, this is the last question for this session. Okay, an on-premises server runs a MySQL database and will be migrated to the AWS cloud. The company requires a managed solution that supports high availability and automatic failover in the event of the outage of an availability zone. Which solution is the best fit for these requirements? You have again got 4 options. Yes, this is option 1. This is option 2, this is option 3 and this is option 4. Okay, As you can see, it is again difficult to navigate through the options. You can take your time, pause the video if you want more time than 10 seconds. I'll provide you 10 seconds itself, and your time starts now. See the fourth option, and I'll again scroll up. Start. Time up. Now let us analyze the answers. Option 1, use the AWS Database Migration Service DMS to directly migrate the database to Amazon RDS MySQL. Use the schema conversion tool SCT to enable conversion from MySQL to Amazon RDS. Okay, option 1 is incorrect. Why? Because it doesn't specify multi-AZ deployment, which is crucial for high availability. Okay, so option 1 is the wrong answer. Option 3, use the AWS Database Migration Service to directly migrate the database to an Amazon EC2 MySQL multi-AZ deployment. Also incorrect, because Amazon EC2 requires manual management unlike Amazon RDS. Okay, so option number 3 is also the wrong answer. Option 4, create a snapshot of MySQL database server and use AWS Data Sync to migrate the data to Amazon S3. Launch a new Amazon RDS MySQL multi-AZ deployment from the snapshot. Also incorrect, because it involves manual steps and doesn't provide a managed solution like Amazon RDS. Okay, so option number 4 is also the wrong answer. Option 2, use the AWS Database Migration Service to directly migrate the database to an Amazon RDS MySQL multi-AZ deployment. This option is correct. Why? Because Amazon RDS MySQL multi-AZ deployment provides a managed solution with high availability and automatic failover across availability zones. Okay, so at the end, your option 2 is the correct answer. You can see. So that's it for today's video. You have successfully answered 5 questions today. Congratulations for that. Please let me know your score down below in the comments. We have more sessions like these for AWS Solutions Architect, and we also have separate playlist for cloud practitioner. If you want that also, there is a playlist for that. If you like our questions, please make sure to like this video, share it with your friends and family who are appearing for the exam, and subscribe to AMG Cloud. That's it for today's video. I'll meet you in the next session with a new set of questions. Till then, keep learning, keep practicing, and keep exploring. Thank you, and bye-bye.